Um, in this video, we want to show how to use mcute, um, which is a concolic testing engine for models of real-time systems. Um, I'm using mcute in PopRSRT, but actually mcute executes in command prompt as well as a plugin in um, PopRSRT. PopRSRT is an Eclipse-based IDE for developing UML-RT models, multi-models, and sysML models. Alright, so I have a model here, which is a simplified version of a larger model, collision avoidance model. So each model in UML-RT consists of a set of capsules, which actually are the components of the system, where each capsule has a state machine. To quickly see the state machine of this capsule, I double click and show it. So as you see here, we have a almost simple state machine, several states and transitions, and on each transition we have action code. As you see here, there's some complex action code here. This nested um, conditions or if statements on the action code makes it challenging for testing tools to increase the coverage. For example, it's challenging for random testing to execute this if, for example, because the tool must generate inputs enough to be able to uh, execute the body of these if statements. So predicates make executing ifs difficult for random testing techniques. So we want to show how concolic testing can be a powerful tool to increase the coverage for testing a state machine. Okay, so to run mcute, we select the capsule, and from the context menu, we select mcute and then test. So a pop-up appears, which actually is the configuration for mcute. Here we can set different parameters to run mcute. So different parameters including, for example, the strategy, which actually is a set of techniques that mcute supports for testing. Our main goal is to present concolic testing for state machines, but we have developed a couple of other techniques as a baseline or as a way to compare the performance of concolic testing as well. So it's possible to choose a heuristic which specifies how the tool selects branches for execution, and then there is execution time in seconds, the total number of iterations. So each iteration is the number of transitions that the engine executes in a row. So in this case, for example, 200 iterations means the total number of iterations is 200 before the tool stops execution. So iteration length is the number of consecutive transitions that are executed, or the total number of transitions in an iteration. And then there is transition iterations, which says how many times the transition can be executed. The last option, if it's true, then some extra information is shown in the execution during the executions. For example, the collected constraints, the inputs generated, etc. So let's start with a simple test using, for example, in this case, random testing. So we want to run random testing for 5 seconds, and we want to see the number of the performance of the technique. So if I run, so the tool starts with uh, transforming this model to a testable model such and integrating it with a test harness. So it takes a few seconds to transform this model, but the transformation happens only once. It means that we can test a model several times, but we only transform it and integrate it with the test harness only once. Okay, so after the transformation, the code generator is called automatically by the tool, and the generated code is built and executed such that the model is automatically tested concurrently. In this case, not concurrently, sorry, because we have already selected random testing. All right, so after the model is built, yeah, the testing starts and it lasts for 5 seconds. In this case, it finished in 4 seconds because uh, the tool could already execute 200 iterations. So the coverage is 75% for the branches, and then all the states and transitions were covered. So if we scroll up, we will see more information here. So for example, the number of branches that were covered. It says, for example, transition 5 doesn't have any branches, but if we scroll up, uh, there's more information. For example, we know that transition 3 has a lot of branches, so 14 reachable branches, 8 of which were explored. Okay, so and here the tool shows the message that was sent by the tool to the model. Okay, so as another execution, I can again run mcute with, for example, um, in this case, using the concurrent test. Okay, so if I run, okay, I get in this case 92% of coverage, right? So uh, yeah, and as you see in this case, um, we can see some extra information in the console, which actually are the constraint collected uh, during the execution. In random testing, the constraints are not collected by the tool, but in concurrent execution, we collect these constraints, and then based on the technique that we strategy that we choose, we negate these branches and we generate new input. Okay, so I want to now catch a bug. So in this case, I want to see how the concurrent testing again is more powerful in catching bugs. For example, if I go ahead and change the transition to action code and just manifest the bug here. Okay, in this case, for example, I'm commenting out this line, which means if P1 and P2 are true, which means if this predicate, the whole predicate holds, and if it's executed, it means that uh, there is a division by 0 here, right? So I want to save the model and see if, for example, random testing or concurrent testing can catch the bug for me. Okay, so if I again choose random testing and run, So as you see, the transformation must happen again because we have changed the model. But as long as we do not change the model, we don't need the tool doesn't transform the model again. Okay. So because naturally the model has changed and the code must be generated again. So the code generator is also invoked again. Okay, so we're just waiting for the build system to build the model. Okay, so model was built and executed. Okay, again, the 75% of coverage, but no bug was found by random testing, because if it finds a bug, basically it must shows that the system has a runtime failure. So let's now choose conflict testing as our strategy and see if this technique can catch the bug. The rank is in the same setup, the same configuration. Okay, now floating point exception. So the system crashes because the model crashes because the technique could execute this if uh, uh, statement and the statement inside the if body of if, and it could find the bug. Okay, so now we stop here. This was a short demo of mcute. So please let us know if you have any feedback, and enjoy.